Hey yo, good evening, viewers of the Tube. I've got a special interview for you today. I sat down with Tom Marchi, co-founder and lead developer for Sentivate, the crypto company focusing on building the hybrid web, a viable replacement for the modern web, which as we know has its problems and isn't ready for a world of connected devices, aka the Internet of Things. Sentivate is a project which I have chosen to advise and help with outreach in the crypto industry, and the details of our interview agreement can be found in the description. So get ready for a deep dive into Sentivate from the man himself, Tom, as he explains how they will be replacing the outdated HTTP and TCP data transport protocols entirely with UDSP. Also cryptography, packet puzzles, their company Arity, and the future roadmap including the transition to Viat. And for those who want to try it out, the Sentivate Alpha Network demos, which include a network client, web browser, and Node.js module prototypes, those video walkthroughs are also included in the description. I sure learned a ton talking with Tom. I'm sure you will too. So without further ado, let's dive in. Yo, what is going on? Viewers of the Tube, Tyler here, Chico Crypto. I'm sitting with the one and only Tom Marchi, co-developer and co-founder of Sentivate. So, Tom, introduce yourself, man.
So I'm Tom, I'm the lead developer for Sentivate. Sentivate is basically a realistic and viable replacement for the web we have today. We're building two networks effectively, although we consider it one. One is the universal web, which is centralized focused, but it has decentralized components. The other one is Viat, and Viat is decentralized focused, but it has some centralized components to it.
So you're building a hybrid web, a new web, because the web today is sick, as you guys say it. Could you explain that further? What's wrong with the web today?
Sure. So there's a laundry list of issues that we're facing today, and there's some advancements we've been making just in the web in general that are trying to kind of alleviate or fix a little bit of these problems. HTTP, the main protocol for the web today, has a lot of the issues that we focus on. Another one is DNS. We like to highlight the mini-malt paper as potential solutions, or at least what I see as a really good first proposal for changes for DNS, and a little bit more. But HTTP 3 is going to change a lot of that because HTTP 3 is a custom UDP protocol. It's effectively quick mixed with HTTP. So it addresses a good amount of the issues we have now, but by no means does it solve it. Mainly because you can't change all of this technology that we have today in a reasonable amount of time. You have to start from scratch effectively. And that's exactly what we're doing. It's not rational for the next version of HTTP to be so drastically different that you have to rewrite all these applications, rewrite how things work, and all of this stuff. So they really just gutted the TCP part, brought in quick, and that's where a lot of the good parts of HTTP 3 comes from. Mm-hmm. They also have zero RTT, but we address it a little bit differently. So zero RTT for us starts from the DIS. So you have a certificate you get from the DIS. So like today, you'd mainly get the certificate from the server. You can do a little handshake, you get the certificate, and then you would set it up. And then after you connect again to it, you can do a zero RTT connection. For us, it's that way by default, where you get the certificate from the DIS. You can immediately set up an encrypted connection, zero RTT, to the end service. Now, again, we'll still leave it, though, up to services to choose if they do want to use zero RTT, because some people do have, some companies, some developers have issues with zero RTT. Mm-hmm. So we want to provide at least some flexibility there, where you can use zero RTT or you can choose a more traditional handshake. Then you can kind of play with that and have that flexibility. That's kind of how we focus with everything. The balance between centralized and decentralized. We kind of want people to kind of choose their own journey, their own path there. Like for Viat, you can opt into wallet security, where you can have your funds frozen if you want to. Say you have some type of issue and there's potentially a hack, you can the rest of the network knows that, hey, look, this wallet here does have wallet security on it, so it's very transparent. It's something you opt into. So we might provide it by default for most people because it's for most folks, it's a very logical thing to have if you
Yeah.
run into an issue. You want to be able to freeze your funds potentially. If maybe theft occurs, you want to be able to freeze those funds if they move to another wallet. And again, both parties that are interacting with your wallet, if you're doing a transaction, will know that your wallet has wallet security on it. So it's good for businesses from a business standpoint, because you want to be able to make sure you have some control over your funds, so you can refund people potentially, or make sure that in the case of theft, you can at least recover some of those funds.
Yeah.
Or in some cases, and what we hope to see is that 100% of the funds are recovered. But yeah, that's all opt-in. It's a choose your own path type of thing. Instant transactions, for example, for Viat is an opt-in. So if you don't want to have, pay a little extra for the fee for instant transactions, if you don't want that, you don't have to have it.
Okay.
You can have, the decentralized portions to it and make, kind of your own choice there.
So basically, you're able to throw your own collage of, features you want to build out your own,
How you
thing
want
that's
it.
going to support your product better.
Right.
If you're a developer and you're building dApp, do you want it to be more decentralized focused or use some of the centralized components?
Exactly.
So your thought is, with a lot of, the Web3 projects coming out, they're saying full decentralization. We want to go fully decentralized. You say that's not possible.
Yeah, it's not a rational choice. It really isn't. If it was, it would have been that way already. There's a reason why, brilliant people at CERN came up with a centralized version of the web that we have today, although it's distributed in some aspects, and you can say it's decentralized in some aspects, specifically in relation to DNS, or just philosophically speaking, we have decentralized people where they're all over the world and they're operating their own servers and whatnot. So in that sense, it's, there's a philosophical argument to be made there that can be at least considered in some respects decentralized. But from a pure network standpoint, and when you're building these things out, it's not. There's centralized bits. You go to a single service, you pull data from that single service. That's the same way for our web initially. You have a centralized service that you contact, and it has some decentralized aspects to it. For a normal service like, say, Newegg or Facebook or something, where there's a logical reason to have a centralized service. If you want those real-time features where, you send an update to the server and then immediately say, if you're instant messaging and I want you to get that message as soon as possible, I don't want to go through a consensus algorithm. I don't want to pay for that message to be sent to you. I have an internet plan. I want to be able to send you a message, no questions asked. This way, in a centralized service, you can go, okay, here's my message. They immediately propagates to you, immediately gets sent to you, and there's a huge advantage there over something like a decentralized network where you have to have a consensus algorithm, and then it has to propagate to nodes, like the mining. All this stuff can get really convoluted and complicated. And basic physics there. If you're sending a packet in space and time, and it's more nodes, it's more space, it's more time it takes to get to everyone to propagate, just simple physics there would say that it's a lot longer than just sending one packet to one destination, computing that, and then you getting it.
Yeah.
That's it. It's very simple there. So it's basic physics where you can just say right off the bat, like, you can improve your consensus algorithm all you want. You can make your mining process as fancy as you want to get. But at the end of the day, if that packet or that piece of data has to go
to multiple nodes.
Right. If it has to go to a bunch of different places, just basic physics would dictate that it's going to take longer.
It's going to take longer.
You can only move data so fast. You can only move so fast. You go, faster than the speed of light, you're going to have problems, obviously. But yeah, so.
So my next question regarding that, what are the most important decentralized aspects and what are the most important centralized aspects?
So for the web, I'd say the most important centralized aspects are like the way servers and services are set up. Now, you can have decentralized aspects to that. So if I want to pull some static files to build whatever application you're providing me with, I can pull directly from you. But there's other people that are maybe using your service, and I could opt in if I wanted to, or if the web wanted you to, the service at that point, pull that data from other people.
Yeah.
So you can get maybe movie files, or you can get just JavaScript files from other people, or image files, something that maybe the service itself isn't really capable of, or because it's congested, or maybe it's just a small server sitting someplace else, but it's got enough users to where you can take advantage of a more decentralized content delivery network.
Yeah. Yeah. So What do you see happening in the future, if we continue with the web we have today and we don't have a switch to something more efficient like what you guys are creating?
So there's a few issues that we could run into, and we're already running into them effectively. Amazon likes putting out stats about like how 100 milliseconds of delay is potentially 1% of profits, and that's an old stat. That's a lot of money, especially now. It's gotten a lot worse. We've heard larger numbers now over time. Obviously, there's more devices coming online. There's the rise of IoT. Your coffee machine has Windows installed. There's some operating system installed on it now, and it can tell you the weather and all this stuff. Your refrigerator, the same thing. You have your smart car now, like a Tesla. It drives for you. It has all these connections going on. All this stuff is taking up more and more bandwidth. It's more and more connections. We only have a limited set of bandwidth, a limited set of space to transfer data. So eventually, if you have all of this data flooding the networks, you have all these machines connected, this huge amount of IoT devices, you're going to run into bandwidth-related issues, bandwidth-related concerns. Any big company that deals with a lot of requests knows about bandwidth-related concerns. So you make optimizations like compressing files or gzipping things or removing spaces from like your JavaScript code, minifying basically. They call it uglifying actually. But you're basically just trying to save space so you can save some time.
Yeah.
But you'll run into a lot of issues like that. You'll run into security-related concerns where you can have something like zero RTT on the web today, but there's a bunch of other concerns like potential attacks that can occur. And a lot of companies, that's obviously not a great thing, but zero RTTs are really cool and it'd be a great technology if it didn't have the same security concerns attached to it.
So my next question for you is, where are you guys in the process right now? How far along are you to reaching your end goal?
So we're pretty close overall. Like a lot of our focus right now is core technologies, but we even broke into now front-end stuff like components, getting assets to the front end, the browser, for example. A lot of people were stressing about, the browser though, and how are you going to get that together? And they had a lot of doubts, and we were like, well, we can just put the browser together now and kind of show you an alpha release of how it would work and how it would function. So that was quite a while out from where we had our projections initially, but because the community basically put some concerns on it, we said, okay, we'll move up our timetable for that and just get it out already and kind of show that, hey, look, it's actually very easy to do. We can integrate it pretty efficiently and pretty effectively. But yeah, like one of the changes that you're going to see with the next update is, so we'll be transmitting image data and video data to the browser. And that's a big shift for us because we're going to be adopting a different format from JSON. It's called message pack. But yeah, we're looking at a few other ones like that. A few other types of basically JSON equivalents. So we're there. We have reactive front-end components kind of coming in now. That was one of the most recent updates where you can build a navigation bar or a sidebar and have all this functionality built into it and have styling, and it'll look way better than the default browser, save you a ton of time, available by default. So, and you have all these additional utility libraries now that you can make use of. So stuff that you would usually include for building, your web apps initially now come with it by default.
Oh, nice.
You're not sitting there focusing on design. You're not sitting there, with, default styled components that just don't look good. Apple did a great job with what they did for iOS, where they made development extremely easy for anyone making a mobile app for them. They provide like kind of a default styling, which looks very good. It's an evolution of flat UI. They did a great job with it, and that's kind of what we're trying to do with our front end. We want to make developers a lot easier. We want to make development a lot easier for developers, where they can
just plug and play.
Right.
Get in there and start building and not have to deal with anything they've never seen before.
Right. Exactly.
All right. My next question for you, Tom, is what is the favorite piece of Sentivate you're working on right now?
So the work that I'm most concerned with and that I'm most excited about is the protocol itself, because every single component effectively uses the protocol in some way, shape, or form.
Yeah.
And plus, it's really exciting to develop it because it has a lot of these different aspects to it. So when you make advancements to it, it affects every other component. So if you make a certain adjustment, for example, we're doing a swap out from JSON to message pack. And that's a huge step forward because it's a lot less data that's being transferred over the wire. So everything gets, benefits from that. But yeah, there's a lot that goes into it: compression, cryptography. You get to work with the browser, you get to work with backend. It's pretty much everything. That's why it's the most exciting.
Most exciting part. So one thing I was excited about when reading through some of your white paper and stuff is regarding packet puzzles. Could you explain that a little bit to me?
Yeah, so that's how Viat ties into the universal web. So there's a bunch of use cases for packet puzzles, and we got this idea initially from the Minimalt paper, which is absolutely a brilliant piece of work. But it can be used for connection liveliness checking, for DDoS protection, to work kind of as like kind of what CAPTCHA does. So you do a little bit of computation, and it can alleviate some network congestion, or it can, in CAPTCHA's case, for example, Google CAPTCHA, it's really just to check if you're human or not. But in our case, it's really just about network congestion. So if you're getting a bunch of clients connecting to you at that point in time, and you want to be able to alleviate some network load, you can give them a little puzzle to solve. And it can be, a varying degree of difficulty, and it can have certain things attached to it, because technically our proof of work is a dynamic proof of work. The second part is, although it's optional and not always enabled, would be a specific use case proof of work. And you would get something more from that, obviously, from computing that. But yeah, Viat ties into it. That proof of work puzzle is effectively a Viat proof of work. For the most part, by default, very, very simple proof of work. You can just validate a transaction, and you put that as your response for your proof of work, for your puzzle, for the packet puzzle. You send it back to the server, and the server can validate that it was a legitimate work and that it was processed and whatnot. And you can get a little bit of Viat mine from that, and the service can actually get a little bit too. But the percentage, the split, can actually be adjusted by the service.
Oh, wow. That's pretty cool. So if we had to go out, 6 months down the road, 7 months down the road, where do you think the project will be then?
So that's where we have, something like effectively a fully operational browser with all of our components, where everything's really easy. You can just pop in, you can be kind of a very entry-level developer and build an app really quickly. We wanted to provide a lot of tools for developers, because it's actually one of our primary concerns. It's making the development environment easy. If you make it difficult, or you have to do all these extra steps like a lot of dApps are, and there's a lot of uncertainty, you don't know, transaction costs and all this stuff, there's a lot of variables there that are unknown variables, and they easily change. We wanted to make it so that you're not going to do a lot of extra, cognitive work. It's very blunt, it's very easy, and it's easier than building a web app that you have today. We wanted to make sure that was the case. We don't want people to spend extra time developing. We want people to spend less time developing. We want to make the learning curve less intensive than building a web app today.
Yeah. So you are going to be calling them hAPPs, hybrid apps, correct?
Yes.
Yes. So explain, how a hybrid app is going to be more efficient than a dApp in Sentivate.
So a dApp is decentralized focused. There can be, there's some apps like DEXs that say they're dApps, and they might be delivering resources from a static location, but they're using the blockchain in some way. But that blockchain aspect severely limits their capabilities. It limits their features that they can offer to their clients, and also limits the type of GUI that they can offer. If you have a centralized service, you can real-time features, no problem. You can set up a WebSocket today and stream assets really quickly, bidirectional between client and server, no problem. For a dApp, you have to, go through this blockchain, you have to go through this consensus algorithm, whatever mining occurs, and you have to wait for this data now to propagate to nodes and be validated on the network. There's a lot of chaos there.
Yeah.
Developers don't want to deal with that. So dApps have a lot of limitations. hApps tried to take the best of what we have now, the centralized portions, but allow the decentralized bits to further enhance it. So you can have like a decentralized, CDN where you're getting assets from a bunch of different clients, and you can still pull assets in the meantime straight from the source if that's what the source wants. The source could potentially say, no, pick up, from the decentralized network and pick up these assets from there. It is perfectly capable of doing that, but in most cases, it will most likely be a combination of the two, where you can get centralized assets and you can also get some decentralized assets that you might need later on. because that is a fallback for decentralized networks, that they take time to discover where the assets are, who has them, and then potentially the person who has the assets might have a slow connection. So there's some drawbacks there. There's a little bit of variability. So it's useful in some circumstances. It's really useful in the sense of, okay, I need these assets maybe 20 seconds, 30 seconds, a minute from now. So you can download it from the decentralized network, be ready to use them and cache them when the time comes, instead of having to, okay, when you need them, I'm going to have to request it from the centralized service. This way, you don't hog up the centralized service, you get your nodes, and also in that process, the person distributing this asset can actually mine Viat by providing a proof of work in that packet. So it could be a series of packets, it could be just the starting packet. It's up to them to decide that. They can tune those settings at that time. The person will do a little bit of work and basically get the asset in the process.
Wow. So let's talk about the token swap from Sentivate tokens to Viat. I know there's some concern about that. We're going from a larger supply to a smaller supply. So could you explain the reasoning behind that?
Yeah, so a lot of people are kind of confused about, I think they mainly look at value, and they're trying to say like, oh, but you're going from 1,000 of these to one of these, how is the value the same? And the example I like to use is if a doctor prescribes you 1,000 milligrams and then says one day, okay, I'm going to just give you a gram, it's the same thing, it's just a different measurement.
Yeah.
So the value is still exactly the same, you're still getting the same medication, it's just a different measurement.
Yep, exactly. So, there should be no cause for concern. We're going to a smaller. The tokens are still going to hold their value.
Right, and there's much more value out of the Viat network than just an ERC20 token.
And what's funny, too, is most tokens, when they do go to a new token model, they usually go to an inflated supply because investors think they're going to get more money out of more tokens. But guess what happens? It stays the same market cap.
Right.
That's what happens. So
yeah, we've heard a lot of concerns about that.
Yeah, I just had to bring that up because people, but people, there should be no cause for concern.
Yeah, it's going to a much smaller supply.
Yes.
So if they apply the scarcity thing to
supply and demand.
Right.
Yeah.
It's much more scarce.
So what's your thing you're most excited about down the roadmap? Like, what do you want to see Sentivate, accomplish first?
Well, I'd like to incentivize a lot of businesses who have, say, desktop applications to adopt the technology. For example, if for Binance's desktop application, they could make use of the tech. They could easily adopt it and have a front-end, a desktop-based web app, sort of like they have now, and make full use of Sentivate tech, of Arity tech. Have it as an hAPP on the universal web where they can make use of UDSP and have, say, higher transactions per second and still consume a lot less resources. Getting companies to jump on board and adopt it where it makes sense to adopt it. It's going to take time. It always will take time, especially if you're introducing new technology. We made sure, though, that we're building replacement technology, not additive technology.
Yep.
So it's not something that you're going to have to add on to your already ridiculous stack at this point. It's something that will replace things. So you'll have a bunch of things you would have to originally worry about. You don't have to worry about anymore.
Mm-hmm. Well, that's pretty amazing. So it's not people going to just, add on a new little piece of equipment. They're actually going to be replacing a lot of the things, which is actually probably going to end up saving them a lot of money down the road, too.
Yeah, exactly. So that's that's a lot of the things we addressed initially to incentivize, obviously, people to switch over to it. And this is mainly from a business perspective. If HTTP isn't cutting it for you because it has a lot of, let's say, issues from bandwidth to processing, whatever it may be that you're dealing with, like essentially we're talking about time. So if it's causing 100 milliseconds of delay, for Amazon, that's a big number. That's a lot of money. For any big company that does e-commerce, like Newegg, for example, that's a lot of money. That's dollars lost. But yeah, if they adopt something where they don't have the same type of concerns, and that's why Google actually created Quick initially. They wanted to save a lot of bandwidth and obviously a lot of money and a lot of time for both them and their user. And they installed Quick and Google Chrome browsers and Google services. So if you're using a Google service at the time, you were using Quick. It still may be active today, but I know with the recent push for HTTP 3 that might most likely be turned off and swapped over to HTTP 3, because HTTP 3 is basically just Quick meets HTTP, which is effectively what they were already doing. They were taking HTTP packets and shoving it in Quick. And that's how they were pushing data back and forth between their services and the client. Obviously, the client still has to have a Google service.
So what do you say to the people that, if you're going up against the giants, like Google or someone, how are you going to get people to switch over to the universal web when, you have the giants who have the money,
Right.
How are you going to get that accomplished?
So they could easily adopt this into their browser. They can easily make use of it.
Really?
It's open source. If they wanted to jump on board with it and make use of it and save some time, some money, some overhead, they could easily do it. I mean, we saw them implement Quick in an update. It popped right up. People started using it. Most people didn't even know they were using it. I would argue probably 99% of the people who were using it had no idea they were using it. They can easily do the same thing. There's no reason why they shouldn't.
So it's not a matter of, hey, we're trying to compete. We're actually, hey, we actually could provide a service to you guys.
Right.
That's amazing.
Yeah, and it wouldn't cost them anything. I mean, they could easily adopt the technology, implement it, and make use of it.
Mm-hmm. And I mean, that's down the road what they might end up doing, because as you know, blockchain technology and decentralized components are going to become a major piece in a lot of different industries,
Yeah, it's going to drive the new web for sure.
Exactly.
There is the next web has to include it. It has to be a part of it because it's become such a important component to the web in general. Just about everybody who uses the web now and who's growing up now knows about Bitcoin, or knows about Ethereum, knows about blockchain. But there's a lot of use cases for it. There's a lot of need for that technology. So to have it a part of the web is a big deal. I think it was the Reddit CEO that came out and said that it would bring about a new web.
Yep.
The cryptocurrency would bring about a new web. It definitely will. It has a lot of use cases. And like, for example, for universal web apps, if you're connecting to it and you have the certificate, the public key can be used to send Viat to them, or vice versa, because if you're connecting to them, they also get your certificate, they also see who you are, so you can make purchases really easily to universal websites, or they could, say, refund you instantly. You don't have to go through this credit card process or any of this. You have cryptography to rely on. You can sign off things, and then boom, you can even donate. You can tip sites. You can do all these things very easily because it's a part now of the way the network functions. Now, I mean, if you have to do a lot of all these extra steps on top of the technology we have now to just do tipping, for example, it's a pain point. But now we have something where everything is just in a single certificate, and it's a Viat wallet. It's also used to establish an encrypted zero-TT handshake. So there's a lot of use cases for this one little thing. It's those elegant, simple solutions that are going to solve really complex problems.
Mm-hmm. Simplicity is the key.
Yes.
Is the key. So could you explain IDs within Sentivate? How identifications are going to work?
Okay, so identity is kind of addressing one of the main pain points we have with the web today, which is how do you distinguish a good guy from a bad guy? And you need kind of a fairly good solution, because you can't have a perfect solution for it unless you introduce new hardware where you have hard stamped IDs for packets leaving a network, where you can't fabricate it or anything like that. It's a part of it, and it's locked up and whatnot. You can't change it or adjust it.
Yeah.
But those solutions cost a lot of money. They take a lot of time. It's all new hardware. It's expensive. And if you want to avoid that, you can only do so much. So for us, your identity certificate, this is where you get passwordless logins, or you don't even have to use a username at that point. You just immediately connect to the service with that zero-T connection, and while you're doing that, the service can log you in. So if you're connecting to, say, Facebook or maybe even Newegg, and you have an account for them, your account is made from that certificate. So they can log you in. So now this thing that you can use for Viat wallets, that you can use to connect to a site, you can also use to identify. So you send over the certificate. If they look at it, they can log you in the process, or they can even instantly sign you up.
Wow.
So they can keep track of your account now every time you go back.
So instead of, going to a website, you go in, then you have to sign in, put in your username, password, you just go to the website, you'll be in.
Right, exactly.
Wow.
And it happens very quickly. And you can really only do that in a logical, viable fashion when the protocol and the DNS service is designed to make the whole certificate exchange happen, where the DIS is given these certificates. It's not just traditional routing information, and then you have to get the certificate back from the service and go through all this handshake process to make all that happen. Now it's just you got the certificate immediately from the DIS. Boom, you can set up a 0RTT encrypted connection to that service. And they can log you in, they can sign you up, you can do instant buys if it's, with Viat. You can make a single purchase. You don't have to sign up for the service now to keep track of things. You can even have a certificate that's signed that's for, say, buying items, so they can request this from you, the service. So if you're buying an item that's shipped to you and it's not a digital download, you can have it where it's basically like a shipping certificate. It's, hey, look, this is my address. It's signed by my certificate that I have, my identity certificate. Here you go, take it. Okay, we verified it. It's good to go. We have all your shipping details now, and we can immediately ship you the item.
Wow. That's going to cut out a lot of time.
Yeah, it's a lot of time saved.
So basically, like when Ethereum and other Web3 projects are coming out, they're basically trying to build, their Web3 on top of the old internet, which they're not compatible, you know. And you guys are going a different way. You're going from the ground up instead of the down or top down.
Right. Yeah, so if you really want to have a viable replacement for the web we have today, you have to readdress it entirely. Mm-hmm. You have to look at it from fresh eyes, understand that we have all this history of the web. We've seen all these problems. We've encountered all these problems. They're well documented. They're well talked about. The mini-mall paper is a great highlight for a lot of those initial issues with DNS. And what that does is it allows us to use hindsight. And hindsight is, it's clear, right? You can look back and everything is 20/20.
Yep, exactly.
But if it was 20 years ago or 10 years ago, we wouldn't have the same conclusions.
Exactly.
We have all this history in the web now that we can look back on, and it all makes sense. But yeah, because we have that, you realize that the problem is much more deeply rooted in the technological aspects of the web. It's not just philosophical. It's not just about, a lot of people like to complain about ICANN and decentralizing DNS. That's not the problem with DNS. It's not an issue of who controls ICANN and what their decisions are there. It actually has more complicated issues. Yeah, that's a concern, but it's not a big issue. A big issue is the way DNS is, the way it acts. It's not. We have DNSSEC now because it wasn't encrypted by default, right? That's a problem. It's an issue. And we're responding to them by putting in additive technology, right? It's not a part of the initial technology. So it wasn't built with it in mind. Yeah. For us, our protocol is built with the DIS in mind, so they work together. It makes sense. Mm-hmm. If you're just building things on top of it, you have all this extra bloat now that's coming along with it. You're not making, true use of the tech that you have. But if a crypto that was using, say, hTTP to communicate with other nodes or to transfer information, they could adopt UDSP in the DIS service. If they wanted to adopt the DIS, they could technically just adopt UDSP and aspects of it and adjust the handshake process a bit, and they could make use of the technology.
Oh, wow.
They could easily adopt it, and it could speed up their crypto, their networking drastically, because now information's going a little bit faster. It's it's not as slow, obviously. It might be the same data being transmitted overall, but the reliability algorithm is much more efficient. So, you're getting the data at the end of the day to the end client much faster than you would with a more complicated or a more chatty reliability algorithm that HTTP has.
Okay. So could you give us any update? I know some people within my community have been wondering when the Viat white paper is exactly going to drop.
So after we're good with the universal web and we know those components are perfect, then we're going to swap over. And we're expecting probably by the end of the year to have all that done. Okay. Where we have hAPPs kind of functioning, all the centralized bits are there. Developers can really kind of have a blast doing it. There's documentation available to make it happen. After that, then we'll look at Viat and go, okay, now we can plug Viat in to all the components, the centralized bits that were actually pretty much core to Viat's functionality. Viat it's a lot easier process because it's basically building off all the technology that's coming from the universal web. Mm-hmm. So there's a lot less to do there. And the more complicated bits is actually the universal web.
Oh, wow. So getting that done first.
It's a much bigger task.
Much bigger. So who are the main guys working on the task right now? How many guys do you have on the team?
So there's me, it's actually Dennis over here. Dennis actually helped recently with the components. So we have a lot of grunt work going on, is what we like to call it. We have Eric, who helped a lot with, although he's not listed. Some developers we don't list because, well, they have concerns. Maybe they have active contracts with something else, or they don't want to be listed on the site because potential harassment or things like that.
All right, so let's talk a little bit next about some of the community aspects. Like you're allowing some community voting on some of the token economics. Could you explain that a little further?
So we hold these Twitter polls that could decide kind of what happens to SNTVT, where the poll might be, you can do a burn, or you can do it for giveaways. You can do a token burn, or you can do it for charity events. So one thing that's very close to our hearts is donating to veterans or donating to animal welfare. That's pretty much our two main ones. Obviously, over time, we'd love to expand and maybe donate to medical research and things like that. But for the most part, we allow the community to kind of decide that and dictate that. So if they say that they want to do a coin burn and they vote in that, they can sign, if they have a wallet holding SNTVT, they can sign a message, and the message can say anything they want, as long as we have their wallet, the signature, and the public key, which they can submit on our Discord in the voting channel, and obviously what choice they want for the vote. That allows them 2 votes per SNTVT. So on Twitter, if we hold the same poll, only 1 vote is counted for, let's say, a choice they have. Mm-hmm. So one say they click, let's say, a burn, that counts only as 1 vote on Twitter. But on, if you're an SNTVT holder, and you have tokens, and you can verify that, obviously, with the signature. If you put that in our Discord, and if we're tallying things up at the time, we'll make sure that it's counted as 2. So if you have 1,000 SNTVT in a wallet, it counts as 2,000 votes. Okay. And you can decide, for us, we also do it where if they decide they want to do a charity event, mm-hmm. We'll also allow them to make the decision of, are we donating SNTVT, or do you want us to do USD? And we'll match if it's an SNTVT equivalent and USD, or if the charity wants BTC or ETH, whatever is preferred. And mainly that is with animal welfare. Mm-hmm. We'd like to do veterans at some point. We have to look into kind of how to carry that out and the best way to go about that. But animal welfare is pretty straightforward for us. If you're doing sponsored foster, if we know someone's fostering a kitten or a cat or a dog or a puppy at that rate, really any animal, and they need some funds maybe to pay for food, pay for some things, or maybe medication that the animal might need, we'll do a sponsored foster. We'll maybe get them some, pay for the food, pay for, whatever the animal might need at the time, and make sure it's taken care of. We've done 2 of those so far. The second one I actually ended up keeping because the cat needed a lot of socializing and a lot of work.
Awesome.
So I took it upon myself to just say, okay,
so you have a new cat.
Yeah.
Yeah.
Yep.
Awesome.
That's Pookie. The community, we also held a vote for that where we allowed them to pick the name for Pookie, and anyone who was chosen out of the name, because it's quite a long name. If you look on our Instagram for the Pookie event, you'll see her full name. It's quite a mouthful. But with that being said, everyone who put a name up and that got chosen in the full name got a certain amount of SNTVT, and it was distributed based on pretty much how much we liked out of each name, which one we liked the most and which one kind of fit the most. That person would get the most SNTVT. Yeah.
That's awesome. So now explain to me how Sentivate and your new web is going to save consumers money.
So the whole idea behind UDSP and the design for the DIS and the way hybrid apps function, it's all about saving time and saving space, saving bandwidth. It's one of the big problems we're addressing. That's why we have net neutrality being a big issue now. If you have all these consumers, all these new devices coming online, you have a lot of new bandwidth. So how do you deal with that? Well, if you're running out of space and you're an ISP or an NSP at that rate, and you have really no technological solution to this, really the only political solution, and yes, there's some technology involved, but it's a political solution more so than anything, you create speed lanes. You offer data prioritization. So certain services, certain sites would move faster than others, and certain people may be on slow lanes rather than fast lanes, and you'd have to pay for that more premium service. Because again, if you have all these devices and have all this activity on the network, there's really only two solutions to that. It's the opposite of what net neutrality is suggesting, and then the other thing is charging people. So you charge per gigabyte, let's say, or charge per megabyte, whatever it may be, depending on your situation. They do that now for certain plans. So you might be paying per gigabyte, and space is a really big deal. If you're streaming, say, video or Netflix and whatnot, or you're using some type of web app on a constant basis, all that extra data can add up to actual money. Mm-hmm. So average people might be paying way more out of pocket, say maybe 10 years, 20 years, really when we are facing these bigger issues. And remember, all this stuff's happening in kind of an exponential rate. So we're getting all these new devices really quickly, quicker than what we expected. And all this new, these devices add up with a lot of new bandwidth. Yeah. That's why we had this whole thing with net neutrality. Now, in the case that it gets really bad, an ISP will have to go ahead and go, okay, look, you can use a fast lane or you can use a slow lane. And this data from this service will be faster than your other services. And that will basically act as a form of network congestion. Oh. So a lot of the things like packet puzzles, for example, help with that. Because you're sitting there, your computer might be, or mobile device at that rate, might be computing this hash or verifying this transaction or whatever proof of work the service wants to give you, because they aren't forced into the Viat proof of work. That's the default thing we want to go with. But if they wanted just a really quick and easy one, they could do their own, as long as it could fit in the packet and obviously the portion that is allocated to that puzzle. Because there's only a set amount of space allocated to packet puzzles. The way our Viat proof of work one works is that it actually is kind of like an ID, and it goes, okay, you have to contact a certain service, typically it'd be our centralized ones, and say, hey, look, you need to verify this transaction. You get the data on your own too, compute the work, and then you just provide basically a verification, which the service can easily verify, quickly verify at that. It can be it could be a signature, it could be an ID to the proof of work itself, and then that's it. That's completed. It's nothing more complicated than that, because if you do, you're taking up a lot of space in a single packet. You only have a set amount of space in that packet. The rule of thumb is usually around 1,000, 200, 1,300 bytes. Anything more than that, you run into some issues. So you have to allocate a certain amount of space to certain things. You can't overdo them. The packet puzzle has a set amount of space that you can find in the code itself. That we expect to change from time to time, with different types of puzzles or different types of maybe work that we might allow. We would obviously increase the size of that. And the switch that we're having from JSON now to message pack is going to save a lot of space in packets, and it's going to further enhance the bandwidth saving aspects to that. But yeah, so there's either net neutrality and the opposite of net neutrality in the future, these speed lanes, or data prioritization. And then obviously consumers are going to be paying out of pocket for the amount of gigabytes they have, maybe for the month or the day, whatever their plan dictates. So having this kind of re-envisioning of what a future web would look like can solve a lot of these problems, but only because we're starting from the absolute base, like absolute nothing, like envision it from scratch, and using the hindsight of all the years of the web as kind of a blueprint for what to do and what not to do.
So that's it. So now my final question for you is regarding, an elevator pitch to someone who you just first met, and you want to tell them what Sentivate is and why they should use it. Let me hear it.
So Sentivate is a realistic and viable replacement for the web we have today, in a nutshell.
That's it. That's the elevator. Well, you heard it from Tom, you guys. That is Sentivate, a realistic, viable alternative to the web today.
Yep.
All right.
It can be kind of extrapolated from there, and it's that we're building a solution that makes sense and has, you know, a good amount of logic, reason, and evidence to suggest that these choices are better than, say, a decentralized web or the web we have today.
Mm-hmm.
It just gets down to pure numbers at that point. You know, transmitting less data, it's a win. It's a win for both parties. It's a win for the web as a whole because now it eliminates a lot of congestion. It's a win for the global economy because now data and therefore money is transferring faster. So if you adopted, for example, a decentralized web for the web we have today, if you replace the web we have today with a decentralized web, you'd crash the global economy. Yeah. Because now you have, you know, Amazon put out the thing of a 100 millisecond delay, 1% of profit, which is, you know, much more now than it was then. If you introduce so much delay because now you have to go through a consensus algorithm, it has to be mined, it has to go through all of this mumbo jumbo just to get a packet to an end, you know, an end service. If it has to go through that, or an action like buying something, you're going to run into a lot of problems. What is it going to do? It's going to slow down that transaction. Now imagine slowing down all the transactions. You're running into a lot of issues there. You're talking about slowing down the web just in general, but also slowing down the flow of money. Because you can have a bunch of ones and zeros in that account, but if you can't send a request to Newegg to purchase an item, those ones and zeros just stay there. Yeah. You know, if you can't transfer anything, if you can't make any requests or any purchases, there's no use for it. So with that being said, if you were adopting a decentralized web as a replacement for the web we had today, if we just completely removed it, you would crash the global economy. You would have a bunch of people out of jobs. The stock market would be moving a lot slower if they adopted, say, just a DEX at that rate. And there would be a bandwidth crisis because the whole consensus algorithm, you're sending this data and you're making all these nodes in this distributed network do all these computations. What is that doing? That's sucking up even more bandwidth than just sending it to the service. You send it to the service, they do the computation internally. They might have maybe some third-party, services to do something like a login with Facebook, for example, where you're getting something from a third party. But even then, you're going to one source only. They're computing something, sending it to you, and it's a rather easy process. If you have to go through all these nodes, now you have a ton more bandwidth issues than you would have with just the web we have today. You're sending way more data, you're having way more nodes talk, and God forbid that you're using, say, not like Bitcoin, which is using raw TCP, you might be using, say, hAPP, which is a very chatty protocol. Yeah. So that en masse, and you have all these nodes now using hAPP, and it's a catastrophe. You're talking about bloating the hell out of networks and creating a bandwidth crisis much sooner than we will eventually face.
Wow. Well, viewers, you guys know I'm a big fan of Sentivate. There's a reason I joined the team. I can't wait to see what happens in the future, and I'm going to be along for the ride as long as we can go. So, Tom, thank you for being on the show, man. Can't wait to have you on again, especially when we are a little bit more down the roadmap.
Definitely.
Yeah. Cheers, man.